Okay, so one more thing to say about displacements. Consider a round trip, some kind of motion in which you end up at the same place where you started. Let's say the bug starts here, and then travels that way and comes back to where the bug started, so that the final location is also 2 meters. Well, displacement is the difference between the final location and the initial location. It's final location minus initial location. But in this case, that displacement is a final location of 2 meters minus initial location of 2 meters, 0. Because displacement tells you the overall net change in location due to all the motion. But overall, the net change in location was 0 because this was a round trip, so the bug ended up at its starting point. There was no net change in location for a round trip. Okay, so that's how we think about change in location, but of course we need to look at one step more complicated. We usually want to know how fast or how slow location is changing. And for that, we have the two concepts of speed and velocity. Velocity is very closely related to displacement, change in location. And the connection, as you saw in the text, looks like this. Velocity, here's the equation that defines velocity. It's just displacement divided by the length of time it took to make that displacement. And length of time will usually symbolize as delta t, change in t, where t itself is what you read on your clock or stopwatch. So in other words, change in location, like any change, is final value minus initial value, and change in time is final time minus initial time. Okay. This is the reading on the clock when you started watching the motion, and at this moment, this was the location. And this is the time when you were finished watching the motion, and at this time, XF was the location. Now, the important thing to notice about this equation here is that you've got a vector on the left-hand side of the equation. Velocity, just like location, just like displacement, is a vector, has both a direction and a magnitude. On the right-hand side, you've got a vector also. Right? The only thing a vector could be equal to is another vector. But in order for two vectors to be equal, they have to have the same magnitude and they have to have the same direction. So that means the direction of this thing is the same as the direction of this vector. And the only piece here on the right-hand side that is a vector, the only piece here on the right side that has any direction to it is this, the displacement. So the direction of this vector here on the right-hand side is just direction of displacement, direction of the change in location. And that has to be the same as the direction of this thing, velocity. So the moral of the story is, direction of the velocity is the same as the direction of the displacement. And direction of displacement is the direction of the overall motion. The direction of the displacement is just the direction in which you move if you're going to go from the starting point to the ending point. That's not a surprising result, but even though it sounds simple, it's important to remember it. If you don't, that'll cause some confusion later on. Okay, now tomorrow we'll try some of all this stuff in class.